Hello everybody, welcome into another lesson. So today we are going to talk about spheres. Now, like their 2D cousins, spheres are very circular. So a circle in plane figures in 2D is the set of all points a fixed distance from a given point in a plane. Well, a sphere is the 3D version of that. It's the set of all points a fixed distance from a given point in space. So you have a sphere. You could think of like a basketball or a beach ball, something like that. Those are spheres. So, of course, you have a radius of a sphere, starts from the center, goes to any other point on the sphere. And then we don't have lateral areas for spheres. You just have a surface area and a volume. The surface area of a sphere is just 4 pi r squared. And then the volume is 4 over 3 times pi r cubed. So spheres are actually pretty simple to deal with. So we'll get started with some examples here. This could be actually a pretty short lesson because spheres are honestly pretty straightforward. Whoops, I'm using the wrong side of the eraser. Wouldn't be the first time I've done that. Alright, so let's see here. We are given a sphere with a radius of 2. So we have a sphere with a radius of 2. We need to find the surface area and the volume. Well, let's find the surface area. The surface area of a sphere, of course, is equal to 4 pi times the radius squared, which would give you 4 pi times what is that radius of 2 to the second power, which would give you 4 pi times 4, giving you a surface area of 16 pi square units. So the surface area of this particular sphere would be 16 pi square units. Okay, now we need to find the volume. The volume, of course, would be equal to 4 over 3, that times pi times the radius to the third power. So that'd be equal to 4 over 3 times pi times that radius of 2 to the third power, which would give you 4 over 3 times 8 pi, which none of this breaks down any further. So you'll end up getting a volume of 32 pi over 3 cubic units. So the volume of this particular sphere is 32 pi over 3 cubic units. So as you see, spheres are relatively straightforward. Okay, so this time, let's say the radius is 8. We have a radius of 8 for the sphere, okay? Well, let's find the surface area. The surface area, of course, is equal to 4 pi times that radius squared. So that would give you 4 pi times that radius of 8 squared, which would give you 4 pi times 64, which would give you a surface area of 256 pi square units. So the surface area of this sphere would be 256 pi square units. Now we can find the volume. The volume, of course, would be equal to 4 over 3 times pi times your radius to the third power, which would give you 4 over 3 times pi times that radius of 8 to the third power, which, let's find out what the heck is 8 to the third power. I honestly have no idea, but I'm fixing to find out. So 8 to the third is 512. So you would have 4 over 3 times pi times 512. Let's see if any of this will break down with 3 in the denominator. Nope, it doesn't. So it would end up being 2048 pi over 3 for the volume. So you get a volume for this sphere of 2048 pi over 3 cubic units for the sphere of this particular volume. And that's very normal to have. So 2048 pi over 3 cubic units for the volume. Okay, a little bit different here. They're going to throw a variable at you this time. Let's say the radius has a length of 3t. So you have a radius of 3t. They're throwing in a variable this time. Well, let's find the surface area first. The surface area is equal to 4 pi times the radius squared, which would give you 4 pi times that radius of 3t raised to the second power, which would give you 4 pi times 9t to the second, which would give you a surface area of 36 pi t squared. That would be your surface area for the sphere, would be 36 pi t squared. Now let's find your volume. The volume, of course, is 4 over 3 times pi times the radius to the third power, which would equal 4 over 3 times pi times that radius of 3t raised to the third power, which would give you 4 over 3 times pi times 27t to the third power. Well, good news is 27 is divisible by 3, so you would end up getting 4 pi times 9t to the third power, which would actually give you a volume of 36 pi t to the third power. So the surface area is 36 pi t to the second power. The volume is 36 pi t to the third power. And I literally have just 3 more problems and then we're done. So as you see, finding the surface area and volume of a sphere is relatively straightforward. What do they give you this time? They give you that the surface area is equal to 36 pi square units. So they only give you the surface area to start with. You still have to find the radius and you got to find the volume of the sphere. Well, since we know the surface area, we should definitely find the radius first, right? What is the formula for a surface area of a sphere? Well, that's just 4 pi r squared. And since we have an actual surface area, we'll set that equal to that surface area of 36 pi. Which divide both sides by 4 pi, you'll get that r squared equals 9, which would give you a radius of 3. So we just found the radius to have a length of 3. Now we can go from there and find the volume. The volume, of course, would equal 4 over 3 times pi times the radius to the third power, which would equal 4 over 3 times pi times that radius of 3 to the third power, which would give you 4 over 3 times pi times 27, Well, 27 does divide by 3, so you would get 4 pi times 9, which would give you a volume of 36 pi cubic units. So the radius is equal to 3 units, the volume is equal to 36 pi cubic units. Alright, I have 2 more problems and then we're done. What are we given this time? We are given that the surface area equals 100 pi. So the surface area of this particular sphere equals 100 pi. We still have to find the radius and then the volume. So what is the formula for the surface area? Well, that's 4 pi r squared. That would be equal to your surface area of 100 pi. Now, you divide both sides by 4 pi, you'll get r squared equals 25, which would just give you a radius of 5. So the radius of this sphere is 5. Now that we found the radius, we can find the volume. The volume, of course, equals 4 over 3 times pi times that radius to the third power, which would equal 4 over 3 times pi times that radius of 5 to the third power, which of course would equal 4 over 3 times pi times 125. So let's see here. Does any of this factor by 3? 125 sure doesn't. Nope. Okay, so the best we can do for the volume is it's going to be 500 pi over 3 cubic units. So you end up getting a volume of 500 pi over 3 cubic units. And I got one more problem, then we're done. All right. Okay. So this time we have, they give you the volume is 4,000 pi over 3 cubic units. So you're given the volume for once. The volume is 4,000 pi over 3 cubic units. We still have to find the radius and then we find the surface area. So what is the formula for the volume? The volume is 4 over 3 times pi r to the third. You would set that equal to your actual volume of 4,000 pi over 3 cubic units. Well, do yourself a favor, multiply both sides by 3 to get rid of the fraction. You'll end up with 4 pi r to the third equals 4,000 pi. Now you can divide both sides by 4 pi. You'll get r to the third equals 1,000. Well, what is the cube root of 1,000? It's 10. So the radius would have a length of 10. So we just found the radius of this sphere. Now we need to find the surface area. Well, the surface area, of course, is equal to 4 pi r squared, which in this case is 4 pi times that radius of 10 squared, which would give you 4 pi times 100, which would give you a surface area of 400 pi. So the surface area of the sphere would be 400 pi square units. And that's really all there is to spheres. So the next lesson, We are going to do a similar lesson to what we did in the 2D unit with ratios of areas. We're going to do ratios of areas and volumes in the next lesson. So I hope everyone has a great day. Take care.